In this video, we're going to look at ultimately net ionic equations. So here we have an equation. We don't know if it's balanced yet. Let's inspect it. We have a lead on the left. We have a lead on the right. We have two nitrates on the left. We only have one nitrate on the right. Nitrate is NO3 negative. So I need to put a coefficient 2 here. So the 2 multiplies the potassium, the 2 also multiplies the nitrate, and that was my intention over here. I need to put a coefficient 2 here because I previously put a coefficient 2 over there, and I need 2 potassium on both sides. That coefficient that I just added multiplies the chlorine, which now balances the 2 chlorines over here. So right now the equation is balanced. As written, if you see an equation of this form, this is a molecular equation. Because I've got a representation of molecules. What we need to do now is to dissociate any ions that can be dissociated. So you notice I've added AQ, AQ, S, AQ. AQ stands for aqueous, which just means dissolved in water. S stands for solid. There's also L for liquid and G for gas that are not shown here. So I can dissociate anything that's aqueous into its ions. So if I write lead 2 plus aqueous, that would be the ion in this compound. It's a metal, so it's going to take a plus charge. And I know it's plus 2 because I've learned that nitrate has a -1 charge, and I have 2 of them. So to counterbalance the 2 negative charges, I need a plus 2 charge. The sum of charges in ionic compounds must always be 0. And I have 2 NO3 negatives. So again, you can see here that a single plus 2 charge plus 2 single negative charges equals 0 charge. So I've separated the ions. I can do it again here. I have 2K plus aqueous and 2, don't need that plus sign there, 2 Cl minus charges. Here I know that potassium has a plus charge because it's a group 1 metal, it's an alkali metal, and all group 1 metals carry a +1 charge, if any charge at all. I know that Cl is a single negative charge because it's a halogen. Well, now it's a halide. Halogens form halides. They're in group 17. They can only gain 1 electron to fill the valence shell. So halides have a single negative charge. If I come to the arrow here, so I'll draw the arrow here as a continuance over here. I can't separate a solid, so I just rewrite as given. So PbCl2 solid. And I can go ahead and separate this. So I have 2K plus aqueous and 2 NO3 minus aqueous. So again, I've separated all separable ions. I've not separated the solid. You would neither separate a liquid or a gas. You can actually only separate aqueous chemicals. So because I've separated ions, this is called the ionic equation. So I've gone from the molecular to the ionic by separating ions. Finally, I want to go from the ionic to the net ionic. And I would do this by cancelling spectators. A spectator is a chemical that is completely unchanged as a reactant or a product. So if you see something either side of the arrow sign that's identical, it's a spectator. So for example, on the left of my arrow, I have 2 nitrate, but on the right of my arrow, I also have 2 nitrate. So they're unchanged, so I can cancel them, and they are spectators. On the left of my arrow, I have 2 potassium cations. Well, they cancel the 2 identical potassium cations as products. Lead does change because here it's a cation, it's an aqueous cation. Here it's part of a solid, so that's different. Likewise, here I have 2 chloride anions, but here it's part of a solid, so they're different. So my net ionic equation is what's different. So it's lead 2 plus and 2Cl minus. And they come together to give my product. So that's it. As you can hopefully appreciate, one of the benefits of learning to write a net ionic equation is it simplifies the molecular equation. It highlights to a chemist what's really happening. So, whereas if you just see the molecular equation, you might think that this is a product. Clearly it doesn't survive as a net product. So although you add this to conserve mass, this is not a true product because it exists in an identical form as a reactant. So it's just stuff that's neither nor, it's a limbo type chemical. This is the only product. So this chemical here is the only product. And you might not notice that if you don't bother to look at a net ionic equation.